Hello students, in this video we are going to discuss the principle of superposition. So this principle of superposition helps us to calculate the resultant gravitational force on any point mass due to others when more than 2 point masses are involved in the system. So basically it is used to calculate the resultant force on a point mass due to the surrounding. So what is this principle of superposition? So this principle of superposition states that if there is an interaction among the number of point masses, then the resultant gravitational force on any point mass, is equal to the vector sum of the gravitational forces exerted on it by the other point masses. So here let us consider 4 point masses, the system of 4 point masses m1, m2, m3 and m4. So these are 4 point masses separated by some distances. Okay. So now according to this principle of superposition, to calculate the resultant force on m1, the resultant gravitational force on m1, first we have to calculate the individual forces exerted on m1 due to these point masses, that is m2, m3 and m4, and then we have to take the sum of these individual forces, and that vector sum of the force gives us the resultant force on m1. Okay. So to do that, first we have to calculate the individual force on m1 exerted by m2. So the gravitational force on m1 due to m2 is the gravitational force on m1 due to m2, and we call that force as F12, vector F12. So that represents force on m1 because of the mass m2, and you know that m1 is attracted by m2. Okay. So and this force is given by Newton's law of gravitation, and then that is G, and then product of the masses m1 and m2 divided by the square of the distance between them. Okay. So here the distance between m2 and m1 can be represented using a position vector, that is position vector of m2 with respect to m1, and we call it as r21, the position vector r21. Okay. So this is the position vector of m2 with respect to m1. Okay. So what we are going to do is, here we will take r21 square and then we multiply this magnitude with r21 unit vector. Okay. So what is r21 now? R21 represents a unit vector, r21 cap actually, r21 cap represents the unit vector along r21, along the r21. Okay. So therefore the force F12 is also along the r21. So this is force F12, force on m1 due to m2. Okay. So this equation number 1 gives us the gravitational force on m1 due to m2. Now the gravitational force on m1 due to m3 is, okay. So this time you have to calculate the force on m1 due to m3, and you know that it is attractive force. So m1 is attracted towards m2, and here the position vector of m3 with respect to m1 is r31. Okay. And then the unit vector of this r31 is r31 cap, okay. And therefore the force on m1 due to m3 is along r31, and that is F13. Okay. The force is F13, and it is the force on m1 due to m3, and that is m13 equals to G m1 into m3 divided by r31 square into r31 cap. So this is equation number 2, and this equation gives the gravitational force on m1 due to m3. Okay. Now the gravitational force on m1 due to m4. the gravitational force on M1 due to M4 is, and this gravitational force is obviously F14. So that is F14. Okay, so this will be R41, that is the position vector of M4 with respect to M1. Okay, and then we are going to take the unit vector R41 cap, unit vector R41 cap. Okay, and the force obviously is along this R41 cap, and that force is F14. Okay, and this F14 is obviously equals to G, product of the masses M1 into M4 divided by square of the distance, that is R41 square, and then R41 cap to represent the direction of this F14, and that is towards M1 to M4. Okay, and let's call it as equation number 3. So these three forces are individual forces exerted on M1 because of M2, M3 and M4 respectively. Okay, now according to principle of superposition, the resultant gravitational force is equal to the vector sum of the gravitational forces. Okay, so therefore the resultant force, the resultant gravitational force on M1 is, and you know that it is the vector sum, so that is F1, and it is equals to the vector sum of individual forces, and that is F12 plus vector F13 plus vector F14. Okay, and you know that from equation number 1, F12 is nothing but G M1 into M2 divided by R21 square into R21 cap, plus F13 is G M1 into M3 divided by R31 square into R31 cap, plus F14 is G M1 into M4 divided by R41 square into R41 cap into R41 cap. Okay, so this equation gives us the resultant force on point mass M1 due to these point masses. Okay, so that's how we use this principle of superposition. So basically this is the principle of superposition. The vector sum of individual forces gives us a resultant force on any point mass. Okay, if there is n number of point masses are present in the system, okay, if n number of point masses M5, M4, M6 up to Mn, okay, then the resultant force on M1, okay, if n number of particles are present in the system, then F1 is equals to F12 plus F13 plus up to F1n, up to F1n. Okay.